Now we will move on to the basic segmentation techniques. The simplest segmentation technique is called thresholding. In thresholding, a range of pixel values is defined for an image. If pixels have a value that is inside the defined range, they are given a new value of 1. If they have a value that is outside the range, they are given a new value of 0. Thus, thresholding results in a binary image. For grayscale images, 3 basic thresholding methods are implemented in the National Instruments Vision Assistant. So they are the global threshold, auto threshold method, and the local threshold method. Also, a possibility of color thresholding is also implemented in the Vision Assistant. There you can choose if you want to threshold the red, green, or blue channel, or if you perhaps want to threshold the hue, saturation, or luminance. So, let's see how to perform the thresholding operation in the Vision Assistant. I have already loaded the image from our previous example, and in the grayscale functions you can find the threshold function. Here, the manual threshold is already selected, and the threshold function is set up to look for the bright objects in our image. So you can change this to perhaps look at look for the dark objects or gray objects in the image. So let's look for the dark objects because our object of interest is dark. And here you can see the histogram of our image, and you can specify the threshold value right here. So if we vary this, you can see that the pixels that satisfy these conditions that are colored blue in our image are changing. So the optimal threshold for this image would be somewhere around here. So our object of interest would be colored blue. Let's click OK to see what we get. And here it is, the binary image that represents the thresholded original image. In the ideal case, 2 distinct peaks in the image histogram will be apparent, and you could perform thresholding by choosing the threshold somewhere between them. So in our case, that is exactly what happens. So we have 1 peak here and 1 peak here. So this peak, as you can assume, represents the pixels that represent background. So let's choose gray objects, move the upper threshold here, and the lower threshold somewhere here. So as you can see, now only the background is colored blue. So there are a few auto-thresholding algorithms implemented in the Vision Assistant that can help you determine the optimum value of a threshold, of course suited for different applications. Here they are, and these methods analyze the entire image histogram. They perform some form of statistical analysis to satisfy some form of predefined condition and give you the optimum threshold value. Let's try the metric threshold, for example. So as you can see, the optimum value, according to the metric auto threshold, is 167 if you want to look for the dark objects. Now, let's delete this and load another image example. This will be the example of an image with a non-uniform lighting, and as you will see, there are a few problems when we have those conditions. When dealing with non-uniform lighting, if you choose to use the manual threshold, and let's look for the dark objects, of course, as you can see, not all the objects that are basically the same color because of the lighting, not all the objects are selected when thresholding the image. If we move this too far, in order to find these objects, to threshold these objects, the objects that are on the darker side of the image are becoming blurry. So, in order to deal with that, we do not want to use the global threshold function, but instead we want to perform a local thresholding. So, the local thresholding does not define the one threshold value for the entire image, but instead, for every pixel, a local threshold value is defined based on his environment, based on his surrounding pixels. So let's choose NIBLAC method of the local thresholding, and as you can see, now all of the objects are segmented from the image, even though the lighting is not uniform. If you have an imaging setup with non-uniform lighting that does not vary over time, so it's constantly non-uniform, then there are other methods to remove this effect that are much less time-consuming. So you need to remember that performing a local threshold is quite time-consuming, and it isn't suited for real-time applications. Now, let's see what we can do with color images. For starters, let's show the color plane extraction function. So I have loaded a 32-bit color image. That is a good example because we have all these cubes of different colors. So color plane extraction. With this function, you can try and extract the red plane, green plane, or blue plane in the image, or possibly hue, saturation, or luminance plane. Of course, you can extract the value plane or the intensity plane. So let's now click cancel, as we will not be needing this function right now. What I want to show you is the color thresholding function. So let's choose this. And with the color thresholding function and with the color model of red, green, and blue, we will try and extract just this yellow cube from the image right now. So as you know, the yellow color ideally has 255 red, 255 green, and 0 blue. So of course in a real image it won't be like that. So we need to try and vary the lower threshold for the red channel to limit the selection only to our yellow cube. Now let's try and vary the lower threshold for our green channel. So perhaps this would be ideal. And in the end, we need to vary the blue channel. So there is a little blue here. Let's vary the blue channel to try and extract only our yellow cube, which will be hard as we have this part of the green cube right here that satisfies these conditions. So probably this will be as good as it can get. So that would be most likely it. So now let's try doing the same thing, but in a different color model, perhaps a hue, saturation, and luminance model. So in order to do that, we will change the hue to a degree where we will have only our yellow cube selected. So it will be, as you will see, easier than doing it in the red, green, and blue color model. So here it is. Now it will be easier to segment the yellow cube from the image.